The tank of today is a formidable ally or a fearsome enemy, depending on whether the individual soldier faces it in battle or follows it into combat. Ideally, as a perfect fighting machine, the tank would combine the mighty firing power of heavy artillery with the armor plate protection of a battleship and the speed, mobility, and low silhouette of a racing car. Actually, the modern tank embodies all these qualities to a degree, while keeping the disadvantages of each to a minimum. Designed in World War I to counteract the machine gun and to overrun trenches, the earliest tanks were little more than armed and armored tractors with top speed of 5 miles per hour. However, late in the war, they proved undeniably their effectiveness. In World War II, U.S. tank men learned many valuable lessons. As a nation meeting the aggressor's challenge on 2 fronts, we were unable to pick our spots for battle. Our tanks were forced to fight under a wide variety of conditions of climate and terrain. Then, in Korea, where rugged hills and mountains kept tanks on roads and riverbeds, their capabilities were restricted, but their mobile, highly accurate firepower was used to good advantage. Used at the outset to neutralize North Korean tank assaults, American tanks later reduced bunker opposition and provided effective anti-tank defenses. In Korea, too, American tanks met head-on and knocked out some of the tank product of the Soviet war machine. American intelligence authorities are well aware of Russia's massive tank production program and of her recent advances in the medium and heavy tank groups. Responsible for establishing and maintaining world supremacy for U.S. tanks is the Army's Ordnance Corps. To incorporate the latest and best technical advances and ideas in its vehicles, information is gathered not only from the Corps' technicians, but from battlefield experience, from industry, intelligence reports, and many other sources. First of many stages in the birth of a tank is the drawing up of the military characteristics of the proposed vehicle, a description of what the tank will be expected to do in battle. The combat arms of the Army and Marine Corps are the customers. Ordnance's mission will be to deliver a tank meeting their requirements. Among the other agencies who will advise and assist are the Corps of Engineers, the Canadian Army, General Staff, the Signal Corps, the Marine Corps, and any others who may have an interest in the proposed tank. After numerous joint meetings, when every conceivable facet of the new vehicle is discussed and finally agreed upon, the Ordnance Committee minutes are written up. After review and mutual approval, the idea is on the way to reality. Project number T-48. Meanwhile, at the Ordnance Arsenal on the outskirts of Detroit at Centerline, Michigan, a never-ending program of tank research and development is in progress. In the modern buildings of the Detroit Arsenal is housed the Tank and Automotive Engineering Center of all the armed forces of the United States. Though in part responsible for acceptance tests of new products, the Arsenal's Components Laboratories Division is chiefly interested in the testing of new materials and the development of advanced components, the basic ingredients of the new tank. The range and variety of the laboratory's tests and experiments are staggering to the imagination. Against future orders, hypothetical engineering and design problems are fed constantly into electronic brains. The answers spell out what actual future field conditions will be in vehicles, like the T-48, which are as yet unborn. To test the tank's final drive gears, a torsion machine exerts pressure up to 1 million inch-pounds. If the gears survive this torture, they're sure to hold up on the battlefield. If destined someday to fight in desert terrain, the tank's engine air cleaners must filter the finest sand and dust. Dirt fed into the cleaners is standardized. By weighing the captured elements on sealed-in scales, the filter's performance is checked. In the fuels and lubricants section of the laboratory, a high-temperature distillation apparatus tells engineers the basic petroleum ingredients in fuels. From the findings, they can predict a fuel's usefulness in the tank. In the battery section, every known brand and model of battery is subjected to extremes of temperature, waterproofness tests, and experiments to determine lifespan. In cell after cell, dynamometers put transmissions and motors through their paces. A single V12 tank engine may develop up to 1,000 horsepower. This would be enough to power 6 or 8 medium-sized passenger cars. The vacuum fusion gas analysis apparatus reveals the strength and toughness of the metals going into the tank shell. The work of the chemistry and welding sections is of special importance because armor protection is one of the primary considerations in a tank. Careful records are kept of every electrode used in an experimental weld. Later, high-velocity shells are fired at the weld itself. When the plate is checked, there is no question about the relative value of the electrode used to make the weld. Just how much stress or strain a key tank part can stand before failure is determined by the tensile machine. It can either stretch or squeeze at a pressure of 400,000 pounds. Less weighty but equally important to the tank driver perhaps is the Weisenbeck abrasion machine, which tests in advance the wear and tear he will give his leather seat cover. In the aging room, artificial sunlight made up of infrared and ultraviolet rays is showered on specimen materials by the Atlas Twin Arc weatherometer. Other natural conditions are duplicated by the materials division. A wide variety of fungi are kept under refrigeration here. When allowed to grow, these microorganisms attack sample cable and wires, showing just how well they can be expected to hold up in certain tropical areas of the world. Less involved, more monotonous, but equally important in the development of the tank are tests conducted in the tire section, where the tank's road wheels are run on and on and on until defects appear. Gymnasticates, a word peculiar to the Detroit Arsenal's scientists and technicians, describes the actions of the turret tester. If an experimental turret holds up after such gyrations, shakings, poundings, bouncings, and thumpings, it is labeled qualified for action in the field. Whatever the findings of such experiments, they are recorded in the special signs and esoteric language of the scientists. Much of the labor of translating complex data is reduced by machines like the universal telereader, which reads the findings of the instrument laboratory in terms of complex curves and types out its reports on an automatic typewriter. Now, when the research and development order for Project T-48 is received in Detroit, a project engineer is assigned by the arsenal. It will be his job to follow the new tank to the production stage. The thousands of tests and investigations performed by the laboratory earlier form a reservoir of information for the project engineer. Skilled engineers of long and varied experience in the tank automotive field now compose a drawing in which are portrayed the tank characteristics first envisioned by Continental Army Command and other members of the Joint Committee. From these drawings, expert craftsmen next construct miniature models. Every part is built to scale. From the several models, one or more will be selected for the next stage of development. A 1/16th scale model of the proposed tank, T-48, offers a three-dimensional check on the layout and installation of parts. Any unforeseen problems are corrected in the drawings at this stage. If Continental Army Command approves of the design and physical characteristics, orders are given for the engineering prototype. The pilot model for Project T-48 is a hand-tailored original. At this stage, the labors of the laboratory come into full view. New components are fitted into the whole like pieces in a jigsaw puzzle. When the finishing touches are put on prototype T-48, the new model will be ready for testing, as a whole, for the first time. In the radiographic laboratory, the 15 million volt Betatron takes X-rays of T-48, searching for hidden flaws in construction. Such tests check the hopes and expectations of the designers. The X-ray photos reveal weaknesses in the tank's parts, just as signs of disease or broken bones are uncovered in the human body. Later, pilot model T-48 is subjected to extreme cold in the low-temperature laboratory. The laboratory is divided into two parts, chill and freezer rooms. When the tank and its four-man crew have been gradually cooled off, they move into the freezer chamber. There, at 65 degrees below zero, performance and reliability of parts will be determined.
All right, boys, kill the motor.
Connections are now made between instruments in the tank and those in the control room.
Ready in there?
It's 10 above zero now. Here we go.
Take her down.
Nine above. Zero. $50 below zero.
You lads better get aboard.
$60 below.
Let me know when it levels off.
65 below and steady.
Okay, let's see if this baby's got the stuff. Turn it over. Turret. Reverse. Boys, I think we've got a tank here.
Once the T-48 engineering prototype has passed the extreme and exhaustive tests at the Detroit Arsenal, the scene changes to the Aberdeen Proving Grounds. Here, the prototype is subjected to a series of field performance tests to uncover any bugs as yet unknown. The miles of grueling test track is the most strenuous obstacle course for vehicles ever devised. After climbing a 60% slope, the T-48 runs over a back-breaking washboard type of road. Then, for good measure, it is sent splashing into an enormous bathtub to proof its water repellency. In addition, T-48 is asked to speed across country, climb hills, ride through gullies, and plow through swamps to prove its work. Every step of the way, a performance log is kept. Finally, from the repeatedly revised and refined experimental drawings, 3 new pilot models of the T-48 are turned up. Working as a group, the T-48s are now studied in terms of strategic and tactical mobility. The T-48s pass this stage with flying colors. At last, the T-48 is approved for production. It becomes now the M48. To get the tank on paper for production requires between 5,000 and 6,000 drawings. Another 2,000 blueprints are needed to portray the new machinery, which must be built to manufacture parts for the M48. Once the tooling has been accomplished and special machine requirements have been fulfilled, production rolls in the traditional and typically American manner, assembly line mass production. The multiple spindle drill bores and taps all holes in the hull simultaneously. Convertible positioning fixtures in the weld shop make it possible to turn the hulls upside down, so that all welding can be done from a standing position. Into the new M48 go approximately 85,000 separate parts. They weigh from ounces to tons each. Once the hull starts along the conveyor belt, in rapid succession are added first the suspension system, steering and shifting controls, the instrument panel, then the final drive, the fuel tanks, followed soon by the ammo frames, and finally the power package. Meanwhile, the turret unit is being assembled in 5 separate stages. Once the gun has been installed, the bore sighting is checked and the traverse tested for hydraulic or electrical failure. The turret is now moved to Station 8, where it is joined to its hull. Studying every element going into the new tank are personnel from the Ordnance Tank Automotive Command's new vehicle training school at Detroit's Fort Wayne. It is the mission of this school to train key personnel and instructors in the service of new vehicles, in this case, the M48. Students come from both Army-wide and civilian sources, some even from allied nations. Here, students learn that the M48 is fast, low-slung, hard-hitting, and as easy to handle as a new car. Its 90mm rifle fires an armor-piercing shell at such high velocity that even many inches of armor plate are doubtful protection. Precision sights combining optical instruments with power controls permit the crew to fire the vital first shot in a tank duel. Sighting is rapid and deadly accurate. The gunner can get on target in a matter of seconds. Machine guns, 30 and 50 caliber, protect the M48 from enemy troops with rocket launchers or Molotov cocktails. At nearby Dearborn is the school's field training and maintenance area. Demonstrations show that the tank's sloping sides on both hull and turret will deflect many direct hits. Head on, the hull presents a curving top and bottom meeting at a knife-edge front. After their months-long training cycle at the new vehicles training school, the students are qualified instructors in the M48. Some will remain in the zone of the interior to teach, while others will join armored units in Asia or Europe, where they, in turn, will instruct more men to qualify as teachers. Their primary task will be to teach the men who drive and service the current medium tank model, the M46, in new handling and maintenance procedures. Soon overseas armored units will be receiving the M48, which is vastly superior to the earlier models in every respect. But regardless of how many improvements may be built into a new tank, the combat vehicle's effectiveness in the final analysis depends on the men who man them. To achieve smooth, coordinated performance requires constant training and practice. In a very real sense, the tank is the heart of the Army's armored forces. Over a period of years, the Ordnance Corps' Detroit Arsenal has developed and refined the principle of a family of vehicles. Take the M48's relatives in the tank family. From the same basic chassis and basic components, like power plant and suspension system, come a whole group of vehicles. The personnel carrier, the cargo carrier, self-propelled artillery, anti-aircraft, utility, and recovery vehicles. Actually, the birth of a tank is a multiple birth. From conception to delivery, it may take from 3 to 6 years. The labors of U.S. scientists, engineers, and skilled craftsmen pay off in a tank that is versatile and rugged, whose general reliability probably surpasses that of any other tank in the world. The M48, should it see service in any new conflict, will prove to be an invaluable weapon in America's defense arsenal. All the dollars and hours, genius and sweat that go into the development and delivery of the new tank have but one basic aim: to help ensure that the U.S. soldier working with and in the combat team of infantry, artillery, air, and armor will find victory in any new contest of arms forced upon him by a reckless aggressor. In World War II, U.S. tank men learned many valuable lessons. As a nation meeting the aggressor's challenge on two fronts, we were unable to pick our spots for battle. Our tanks were forced to fight under a wide variety of conditions of climate and terrain. Then, in Korea, where rugged hills and mountains kept tanks on roads and riverbeds, actually, the modern tank embodies all these qualities to a degree, while keeping the disadvantages of each to a minimum. Designed in World War I to counteract the machine gun and to overrun trenches, the earliest tanks were little more than armed and armored tractors with top speed of 5 miles per hour. However, late in the war, they proved undeniably their effectiveness. American intelligence authorities are well aware of Russia's massive tank production program and of her recent advances in the medium and heavy tank groups. Responsible for establishing and maintaining world supremacy for U.S. tanks is the Army's Ordnance Corps. To incorporate the latest and best tech, their capabilities were restricted, but their mobile, highly accurate firepower was used to good advantage. Used at the outset to neutralize North Korean tank assaults, American tanks later reduced bunker opposition and provided effective anti-tank defenses. In Korea, too, American tanks met head-on and knocked out some of the tank product of the Soviet war machine. The tank of today is a formidable ally or a fearsome enemy, depending on whether the individual soldier faces it in battle or follows it into combat. Ideally, as a perfect fighting machine, the tank would combine the mighty firing power of heavy artillery with the armor plate protection of a battleship and the speed, mobility, and low silhouette of a racing car.